Good morning and welcome to this webinar on practical fire and gas mapping using DELOS. My name is Andy Lawson and I will be your host today for this webinar. My colleagues Lorna and Shamsu will be giving the presentation and demonstration, and I'll let them introduce themselves shortly. But first, let's start with a bit of housekeeping. Can I just make sure that everybody has their cameras switched off, their microphones muted? That will help with our bandwidth on this webinar. And additionally, if you look to your top right, there should be a little question mark. So throughout the webinar, you can ask questions as you wish. And at the end of the webinar, we will have a questions and answers session where we will go through your questions. We will also be recording today's session, and I'll send out a link to the recording afterwards. But without any further ado, I will hand myself over to Shamsu.
Thank you, Andy, and welcome everyone. A bit of introduction about the presenters, myself and my colleague Lorna. I'm Shamsuddin Hassan. I am a senior consultant with ESR Technology. I have more than 10 years experience in fire and risk engineering, and prior to joining ESR, I worked with ACOM for several years, and since joining ESR, I've been involved with fire and gas mapping really since 2014. I will now hand you over to Lorna to introduce herself. Over to you, Lorna.
Thank you, Shamsu. My name is Lorna Henson. I'm a principal consultant at ESR Technology. I have 20 years experience of safety and risk consultancy, primarily for the offshore industry. I started my career with Atkins in London and then moved to the Netherlands, where I worked for Vectra for 10 years before relocating back to the UK and becoming part of the ESR team. Thank you, Shamsu.
Thank you, Lorna. So the presentation objectives is really to briefly go through an overview of fire and gas mapping, and then we delve into the DELOS software to give you a flavor of what it is. And then after that, Lorna will be doing a demo on a project to see how it's been applied really. And then towards the end, we'll have interactive Q&A session if there is any question that you may have. But before getting into the into the presentation proper, a bit about ESR Technology. We are an independent specialist technical consultancy company. We provide services to oil and gas, space, industrial and transport sectors. The company dates back to 1950s when UK Atomic Energy Authority was established. What became USR was part of the research and development arm of the authority. It got privatized in the mid-1990s to form a company called AEA Technology, which then metamorphosed into ESR. We have more than 70 permanent staff distributed over 3 offices in the UK. We do develop state-of-art tools and softwares, which we use in-house, and also we do that for different companies and regulators, including HSE. As part of our safety and risk management services, we provide QRA, consequence modeling, fire engineering, expert witness, etc. So going back to the presentation proper, what is fire and gas mapping? Historically, the fire and gas requirement for a platform is done based on a rule of thumb or visual. Actually, people will go on the platform or look at the drawing and think, well, we have a requirement for detecting fire and gas. We can place a detector in X, Y location, and we think it's going to provide coverage. However, in the mid-1980s, regulators and operators have started thinking of, well, we need to provide an objective assessment of these detectors, whether they can work as expected or whether there is any coverage that they're providing or any blockage. And that led to a few operators starting to have a formalized guide just to give an idea of how to do that. And then in the 90s, as computers begin to have capability that moves into a computational field, but I think around that time it's mainly in 2D form. But then as the capability of computers improves, we move into the realm of 3D, and that is what our software does. So really the aim of any mapping is to provide an objective analysis of detector layout and then optimize those detectors so that you meet any coverage that you required. In order to achieve that, there are components that need to come together. The first component obviously is the input data, which is your 3D model, detector characteristics, and also the fire or gas target that you wanted to detect. And then you also require the for any compliance, you need a standard or guide for regulatory compliance. And then obviously you will need a 3D software which will do the work. And at the end of the day, have an informed design. So that takes us down to our software, DELOS, which is an acronym for Detector Location Optimization Software. It's something that we started in 2013, and that was in response to client requirement. We've been approached by clients to do a 3D mapping for their platforms, and at that time there is a limited suitable product in the market, so we decided to develop the tool. And it was designed really to model fire and gas detection within a 3D geometry and calculate the output coverage statistics for each area. And over that time, from 2013 onward, we have deployed it on several projects, both onshore and offshore. And we've gained experience, and as we're gaining experience, the software it's getting updated to reflect that. In 2020, given the advances in technology, and we have upgraded the software, increasing its capability and features, and also improving user interface. And then we have it available for purchase really from 2021. So really the upgrade that we have done has taken into account the previous experience of a wide range of projects that we've carried, and also feedback from both the consultants that have been using the software and also the customers that we work with. And at the end of the day, what you have is a software which is very quick to get started, very easy and intuitive to use, and also efficient and practical. When we were developing the software, what we had at the end in our mind is that this is something that is going to be used by engineers, and we try to optimize it so that the overall acquisition cost for a software, in most instances, companies spend a lot of, they have to take out a consultant from a fee-paying job to go and spend several days doing the training to start using the software. We try to minimize that so that it's quite really is very quick to get started, and we're happy with what we've done. So the software itself developed support different 3D model type, including DGN, DAE, and so on and so forth. And also it enables different detectors really to be modeled. You can model flame detectors, point detectors, line of sight. And the good thing with this is that on some softwares, you probably need a different file for each of your models. So you need a different file to do a flame detection. You need a different file to do a point, gas detection. For this one, you can actually put all your detectors in one file, and you turn off flame detectors, and then you do your gas detection analysis. You can turn off then the gas detection, and then turn on back flame detection and do your flame detection analysis. So it's better that way. And at the end of the day, what the end user want really is a software that's maximize the coverage for a certain number of detectors, and also ensure you use the appropriate number of detectors. Minimize the number. You don't want to overpopulate your platform with unnecessary number of detectors. The main features of the software is, as you can see on the screen, but I'll probably be picking a few of them to elaborate more. One very important one from our point of view really is this live 3D rendering. So traditionally, when you put a detector, you wouldn't know whether the location it is put on is the optimum. You have to like run the model and then check to see whether that is optimal, or you maybe move it a bit and then run it again. With this 3D live rendering, what it does is you can see on the fly. You put a detector, you can turn on the obstructed view, which shows you the view that the detector see with all the obstruction in place, and then you can move around the detector, and as you move around, it tells you whether the coverage it's providing is optimal, or whether it's better than the previous location or not. So that helps in reducing, especially for a complex model, and reducing the number of reruns. Also, what we have is customizable detector properties. It allows you to customize your detectors depending on your criteria, and also it allows you to have multiple detectors, from different vendors, so that you can run your model using those different detectors and see which one gives you a better coverage. Sometimes the client won't have a particular detector at mind, so you can play with different ones, and then you can choose which one is the best. And then another one is the flame. The results. It allows you to have a complex arrangement of flame detection for alarm and control action, and also the interaction of different detectors to provide coverage. And what you ended up having, obviously, is, in terms of result, is you can have a 2D results in contours like this, which shows you coverage provided by each detector. So like this one, this is the coverage for alarm, and then there is a coverage for control action, and then the interaction between different detectors as well. And also you can have your result in 3D on ISO surface, which shows you whether you have a single detector coverage, a multiple detector coverage, or zero detector coverage. And obviously there is a detailed statistics reporting either for your area of interest or for individual detectors. You can see how each individual detector is contributing towards the coverage, and you can see the overall coverage of your area of interest. And then all the images can be readily exported. The statistics and the images can all be readily exported to your reports. That is the end of this brief presentation from me. I'll now hand you over to my colleague, Lorna, for the demo. Over to you, Lorna.
Thank you, Shamsu. So to carry out a fire and gas detector mapping study, we first need to have a 3D model of the facility, and this will be loaded into DELOS. Often there'll be an initial proposed detector layout, and this can be used to position the detectors. Then we need to specify the calculation boundaries and calculate the initial detector coverage. Depending on the results, we can optimize the number, location, or orientation of the detectors to ensure the coverage is appropriate and meets the required targets. So now for the next 20 minutes or so, I'm going to run through a live demonstration and show how easily DELOS can be set up for fire and gas mapping scenarios. So I'm just going to share my screen, and hopefully everyone can see my screen with the DELOS app open.
Yes, you can see.
Okay, good. So first of all, I'm going to load a geometry. This is done by selecting Load Geometry from the File menu at the top and navigating to the 3D model that you want to use. As mentioned earlier, DELOS can load several different file types. For this webinar, we're going to look at an offshore platform. There it is. It's very easy to navigate around the model in DELOS. You can zoom in and out using the scroll button on your mouse, and you can orbit around the model using the central mouse button. The axis lines indicate the origin point of the 3D model, in this case the jacket leg here on the left. There are also viewing options in the view menu at the top, and you can select the camera angle that you would like to view from. There's some options here. This can be really useful if you get disorientated when looking at a large model. It just brings you back to a point that you're familiar with. The fire and gas detection provided on each platform deck would normally be assessed separately. So if we want to look at the main deck, it's very easy to clip the model using the visualization tool here on the left. By using the top clipping plane, I can incrementally clip away the top deck and navigate to the deck I'm interested in. And there's the main deck. To increase the visibility, if you have a very congested platform, or if you're only looking at part of a deck, it can be helpful to clip away from the sides as well. But sometimes it's useful to keep structural features such as the stairwells here, just to aid navigation around the model. Using the clipping plane doesn't remove the geometry from the physics engine, it's just purely to help with the visualization. So now we can have a look at the detectors. If I select detectors in the object tree on the left, it opens the detector properties below. Different flame and gas detector types can be specified within DELOS, with the properties such as the field of view and the range modified to suit the particular detector. So there are a couple default styles already set up. I'll just give this one a name. And then looking at the main deck, which is open between the well bay and the process area, forming one fire zone, I'm going to start with 2 flame detectors. So I can just zoom into my model, and then if I click on the support beam over here where I'd like my flame detector to be located, and then choose the icon in the top toolbar, there's my flame detector added in that location on the model. And I can adjust the location using these options on the left. The unobstructed field of view is shown in green here, and I'm just going to swing the angle around a little just to cover the area. I can also look at the obstructed view just using this tick box here over on the left, and this gives an immediate idea of how good the detector coverage is. And I can move the detector around, and the obstructed view is generated live, which for a very congested model immediately helps with optimizing the detector location. So I'm just going to pop that one back and just move it slightly away from the support beam. So I can turn off my obstructed view, and I'm going to spin my model around and choose a location here on the opposite side to add a second flame detector. And as from before, if I just zoom out and look from above, I can quite easily adjust the angle of the detector to bring it around and cover my well bay area. And again, I'm just going to move it slightly away. And I can also just check the obstructed view and make sure there's nothing immediately obviously blocking my detector. And again, I'm just going to turn off the view just to keep my model clear while I continue setting up the scenario. So now I need to set the calculation boundaries, and I'm going to add a calculation volume by first clicking on the approximate midpoint of the deck and then selecting this box icon at the top. The calculation volume specifies the boundaries that the calculations will be performed for, and only detectors located within this volume will be taken into account. The volume can be sized using the dimension fields over here on the left, so I'm just going to increase it just to fill my main deck area and just reduce the height. The location of the volume is based on its midpoint, so I'm just going to make sure these are in the center and just reduce the height. And I can see that my calculation volume is sitting nicely on my main deck. And I can just use this tick box just to hide that from view as well. So the next step I'm going to do is add a slice by using this icon at the top. The slice defines the height for the 2D results, and as for the calculation volume, I can just modify the dimensions over here with these fields. And again, I'm just going to adjust for the center point. Multiple slices can be added to the coverage results. Multiple slices can be added if the coverage results are needed for different height levels, but I'm just going to use one slice for this analysis. So now the slice is defined, I'm going to add a background image. This is really useful for showing the results as a 2D image on a plot plan or a fire and gas detector layout drawing. So to add a background image, I just select the tab here and then just click on the 3 dots and navigate to my plot plan. And the image can be seen by selecting the 2D view tab just here. It's important to link the background image to the 3D model so that the results are aligned and plotted correctly on the background image. And this is done simply by setting the scale and the origin using the button down here on the lower right. So the scale is set by drawing a line. I normally choose between 2 jacket legs because the distance between those is usually quite easy to find on a plot plan. So I just click on the Draw Scale Line button here and then click on my first jacket leg, carry the line across to my second one and click again, and the line turns green, and I can just enter the distance here in the scale line length box. And then the origin is fixed by placing a known location using this button, and I know this jacket leg is my origin, which has coordinates 0, 0, and I can just click Save over here. And now my 2D image is linked with my 3D model. If you're following a standard or guidance that uses graded areas for your flame detector coverage, for example, having higher risk zones around process equipment with a lower risk buffer, these can also be added easily to the model, and the calculations will take into account the detection ranges for the grades and provide the coverage results accordingly. So first, to define the graded areas to be included, if I select grades here in the object tree, this opens the properties below, and the graded areas can be defined with ranges added, depending on the size of the fire that needs to be detected within each area. So I've already set up a medium and a low risk graded area, and they've got ranges for alarm and control action. So to add a graded area to the main deck, I select this icon at the top, Add Graded Area, and then this opens the graded area property view down below. So I can give my area a name. I'll just call this one medium risk, and I can select the grade type from this drop-down menu. To define the area on the model, I can either type in the coordinates by adding points here in this table, or I can choose to draw the area by selecting this button here, and that takes you to the 2D view. So now I can draw my graded area. I just click the corners where I want my medium risk area to be. And the outline in green there shows my medium risk graded area. So once I click on Save, the coordinates are automatically entered in the table over here. If I want to add a lower risk buffer area around this, I can simply add another graded area. Again, I'll just give this one a name. This will be my low risk area, and it's defined as the low risk type here. I can add a boundary. I'll use 3 meters, and then I can just copy the coordinates from my medium risk into my low risk, and that defines that area. To check that they're how I want them to be, if I go to my slice, I can choose Plot Graded Areas and then select it from the drop-down menu. And there I can see I've got my green medium risk area with my blue buffer around it. So if you're not using graded areas, this step can just be missed altogether. And now we can look at plotting the detector coverage, which can be done either clicking on this button here, or there is a Run menu at the top. So in the background, DELOS is now performing hundreds of thousands, possibly millions of raycasts to determine the visible volume. DELOS contains a number of calculation options to account for factors such as the fraction of a fire visible and composite images across multiple layers. Here we're using a standard visible volume approach. So here we can see the coverage results are shown on my slice in the 3D model, or I can go to my 2D view tab and select from the drop-down menu to see the detector coverage on the background image. And the blue area represents a single detector coverage for alarm, the red is showing coverage for control action, and then the orange overlap in the middle shows coverage for 2 detectors for control action. There's also a statistics tab which summarises the detector coverage for alarm and control ranges for both the medium and the low risk graded areas. It's also possible to view 3D results on the 3D view tab. Isosurfaces can be plotted showing the coverage for different numbers of detectors, and this option is within the calculation volume and the calculate tab. So from the drop-down menu, I can choose whether to plot the detector coverage, which gives a 3D version of the results we've just seen on the 2D slice, or I can specify the number of detectors to plot the coverage for. If I select 0 coverage and then generate isosurface, DELOS will present the volumes within the module where there's no detector coverage. And this can be really useful in helping improvements to the detector layout to be focused in the appropriate places. So I'm just going to hide the slice and brighten up the colour of the isosurface a little to make it more easy to see. And now we can clearly see which parts of the deck are not well covered by the existing detectors. All the red is showing 0 coverage. So I'm going to add a couple more detectors. I'll just hide that isosurface. So again, I'm just going to zoom into my model and just select a beam here to add a flame detector. And again, if I look from above, I can just swing the angle round a little, and I'm going to move it a little bit that way too, and just take it away from the structure there of the stairwell. And I can just check using the obstructed view that my detector has a good view out across the area. So I'm going to just spin the model around and add another detector over here on this beam. And again, I can just easily adjust the angle around a little, and I can check the obstructed view just to make sure that it's not too close to the staircase. I'll just move it a little bit away from the structure. There we go. So now I can run the detector coverage plot again, and hopefully we'll see much improved coverage. I'm running DELOS on a laptop at home. My laptop's 5 or 6 years old, so it's not the fastest machine, but the DELOS calculations don't take very long at all, and the results are soon shown. It's going to show the slice, and there we can see the outline of the detectors is already coming up. And now we have our final plot. And again, looking on the 2D view, we can see that the coverage is significantly better, with most of the module now being covered by 2 detectors. So if I go back and run another isosurface, we should be able to see that the volume showing 0 coverage is much less than it was before. Again, I'm going to just hide the slice just to make it easier to see, and we'll show the original isosurface and just brighten up the colour of this one a little. So we can see now the blue area, or the blue volume, is showing the parts of the deck where there's 0 coverage, which is much less than it was before. So all these images can be readily exported from DELOS to put into reports simply by using the camera icon here at the top, or on the 2D view tab, there's also an export button. So we've had a look at flame detectors. Now I'm going to quickly run through gas detection. First, I'm just going to turn off the flame detectors so that we don't get any confused results. And I'll just remove the graded areas that we don't need anymore. And if we go to the 3D view, we'll just hide these isosurfaces too, just to keep the view nice and clear. So adding gas detectors to the model is very similar to adding flame detectors. I'm just going to do this from above. It's quite easy to see. So I just click on the model in the location where I want my gas detector to be, and then choose the point gas detector icon in the top toolbar. And that places the gas detector on the model in that location. The position and the height of the detectors can be tweaked using the options over here on the left. Now I'm just going to quickly run through and add a grid of 6 detectors. Just going down through here. And if I just look from the side, I can see that all my detectors are on the deck level, which is not where we want them to be. So I can just select them all and increase the height. And then I can just go to my slice and choose the plot detector coverage, just like before. And if I show the slice and go to the 2D view tab, we can see there's our gas detectors. And the calculation's just finishing running, calculating the coverage. And there we go. We can see the blue circles showing the detector coverage with a small bit of green overlap. And on the statistics tab, we can see the coverage is 76%. Similarly to the flame detectors, I can generate isosurfaces to show the results in 3D. And there's also an option under calculation volume to calculate the largest undetected volume. Just selecting this button here. And this looks at the largest volume which cannot be detected by any detectors. If the undetected volume is above a certain size, this implies that if ignited, it could generate overpressures above a threshold, which is something we want to avoid. So the calculation is just finishing, and here we can see with this orange sphere the location of the largest undetected gas cloud. And if I just have a look here on the left, it gives me the volume and the location. So that's a quick look at the gas detection. And just to summarize, we have loaded the model geometry, placed flame and gas detectors, set the calculation volume and the slice height, defined graded areas, and generated 2D and 3D results, which is a quick overview of how you would set up a project from start to finish in DELOS. Hopefully this has provided a flavour of some of what DELOS can do. If anyone would like any further information or demonstration of other features, we'd be happy to arrange that. I'll hand back over to you, Shamsu.
Thank you, Lorna. Let me see if I can take over. Let me know if you can see my screen.
Yes, we can see your screen.
Okay, that's good. So there is just one or two slides really outstanding. So in summary, the DELOS key benefits, which we are very happy with, is one, it's been tried and tested. We have used it and verified on very wide range of studies and projects since 2013. It is intuitive and easy to use, really. I always think of Google when I open it, and the aim really is to reduce as much as possible any cost that engineers will have to bear in order to get to speed on using the software. And finally, it's cost effective, is very quick and efficient to use to get your results, as Lorna has shown. And then we can go to the question and answer session. Can I hand it over back to you, Andy, if we have any question?
Yes, thank you, Shamsu, and thank you, Lorna, for the demonstration. I'm just going to quickly try and get through some of the questions we've got, just trying to collate them some together. Again, let me just remind you of the Q&A functionality. So if you just click on the little question mark, you can ask any questions you have. There's a question. So I think this is to yourself, Shamsu. You kind of touched on it in your presentation, but what sort of guide or standard do you use to follow a typical fire and gas mapping study?
I think it varies really from project to project. Usually, the guidance that one follows is determined from the project's requirement. Previously there isn't there hasn't been that much international guidance around, but recently this has been developed. So we have a new British standard. We have ISA TR84 standard. But prior to that, a greater number of projects use BP Guide, which what seems to be like a gold standard guide at the time. So really, in terms of guide, DELOS is well attuned to use multiple different guidance depending on the project requirement. And also it allows for a complex detection criteria really for flame detection mapping.
Okay, thanks, Shamsu.
Yeah.
It's a little bit of a similar question, actually. Is it possible to actually perform scenario coverage analysis with DELOS in accordance with ISA TR84?
Okay, I guess a bit of clarification. This applies to flammable gas detection. It doesn't apply to flame detection. And the answer is the DELOS, as is being developed, is a geographic or volumetric based fire and gas mapping tool. There has been ongoing dialogue really in the industry about scenario based mapping. And obviously there is obvious pros and cons on each approach. There hasn't been any real consensus really on the best approach. I guess each approach needs to be looked at or considered individually, which is something that came up in the recent British standard, really.
Okay, thanks, Shamsu. I hope that answers the question that was asked.
Yeah.
I think this is quite related to what you were doing in your demonstration, Lorna. I think you mentioned you were using your laptop, but does DELOS actually require a high-end computer to run? Is it a bit faster if you use a faster computer?
DELOS can run on most modern machines. It does make use of multi-threading, so it scales with processing power and with better graphics cards. It's recommended to have at least 8 gigabytes of RAM because some 3D models can be really large, but DELOS does offer mechanisms to cope with memory issues, such as only loading relevant aspects of a geometry. So I think most computers would be fine.
Okay, thanks, thanks, Lorna. I guess we could also, if anybody had any queries about the software, you could always get a demonstration version of it to make sure it works with your computer. So yeah, if you want a demo, just feel free to contact us and we can always send out a demo. Let me just quickly go through the other questions. Maybe it's to you, Shamsu. Does DELOS contain a detector database?
The current version does not contain detector database, but it's something that we have actively done that. Obviously, we're constantly seeking ways to streamline user experience, but the aim really, we wanted to have a user that would be actively involved in prescribing the detector characteristics. What often happens is that the detector manual from the vendors changes. Some of them, I think, I observed one, they have like 4 different versions per year, so they change their manual quite frequently. And if it does have a database which the software is shipped with and people just use that passively, things could change that could affect the project and without people getting the software, the detector details updated. So our aim really is to get an active user base who will actually go and get the latest version of the detector characteristics to put in the model. However, if if the users think it's helpful to have a database with some caveat, we can put that quite easily.
Okay, thanks, Shamsi. I hope that answers that question. Let me see. There's a question on training. Do we offer training? I could probably answer that myself. As a company, we actually do offer a wide range of training courses on various things, HAZOP, HAZID, etc. I don't think we have a off-the-shelf fire and gas mapping training course, but that's something we could obviously do on request, either on fire and gas mapping itself or on using DELOS. So actually, Shamsi, could you just pop up the details, the contact details, please?
Okay.
So if you were interested in that, that's the details of Shamsu and his colleague. So just contact us if that's something you're interested in. Let me just see what else do we have. We've got a few minutes left for questions. So somebody's raised a question, Lorna, about when you were placing the detectors. It was noticed that you were placing those manually. Is there a automatic detection or a way of optimizing the location of detectors?
Yes, DELOS does have a simple anagenetic optimizer built in. So the simple optimizer is a good choice for finding the best location for a single new detector and keeping the existing one fixed. And there's a genetic optimizer, which is a good choice for new or unknown layouts with many variables. Both optimizers offer benefits to offload the thinking to a computer and leave it for a while, but the design philosophy of DELOS is such that these modes are not really required, and with sufficient kind of insight and knowledge, a human will generally still beat a machine in a short amount of time.
Okay, thanks, Lorna. Again, and maybe another question for yourself. I think I guess the software is 3D mapping, but you produced a lot of 2D results. Can you also produce 3D results?
Yes, along with the zero coverage isosurface that I demonstrated, there is a single command to perform multiple isosurfaces to display the 3D equivalent of the 2D plot. But the 2D plot is normally really good for presenting in a report because it shows a nice clear image, and the 3D isosurface can be a little more complex to interpret.
Okay, thanks, Lorna. See, here's a question. Can DELOS calculate the number for areas of 2 or more detectors? Or can DELOS generate numbers for areas that are detected by 2 or more gas detectors?
I think I can pick that one. Yes, I think the results are customizable, and there are a lot of output which can be interpreted to answer a number of queries, really. So I think in simplistic time, yes, it can.
Okay, so it's quite flexible then for doing that.
Yeah.
Okay, excellent. Let me see. Actually, there's a couple similar questions around fusible plugs. So how do you use fusible plugs in the software? Because I think it was noted on the slides, but we didn't actually show it in the software itself.
Yeah, I guess, yes. I think what it does, DELOS assign an appropriate detection level for fusible plugs, e.g. control action. And then it does assume a fire of a certain radius will be detected by the fusible plug. And then on that triggers the plug, obviously. So a composite image of the flame detector and fusible plugs can be generated from that.
Okay, thanks, Shamsi. I'm growing very wary of the time. It's I think we've probably reached our 45-minute limit. I don't really want to take anybody else's valuable time. But what we will do is we will produce a recording of this webinar, and I will also note down these questions that we didn't have time to get to, and we'll try and maybe when I send out the recording, I'll send out answers to these questions as well, just to make sure that everybody's questions are covered. So apologies if your question wasn't answered now, but I'll try and make sure that with the recording we cover as many answers as possible. But I'd like to thank you again, Shamsi and Lorna, for your great demonstration and presentation. And also thank you everybody who's attended today. I hope you found this useful. And I'll say goodbye. Thank you.